today we can start with channels.
Go routine is like, how does it work, right? Or
Yeah.
okay, actually, I think there is a one great this thing. I'll
Mhm.
show you that as well, which I first used to understand. And
Because Go routine and channels very important. Na.
yeah. So this one. Okay. Huh. What is this? Yeah, I think this is the one. Let me tell you. So there is this Andor Labs. Okay.
Mhm.
I said like, okay, in short, right, what Go
Mhm.
routine is. So like you have to think of your this way. Okay.
Mhm.
So uh, let's say you have a laptop, right?
Yeah.
In each our laptop, there are multiple cores are
Processor.
there for
Course. Yeah.
cores, right?
Mhm.
And generally, what happens, right? In nowadays, in at least in Windows, I'm sure that
Mhm.
happens in my Mac OS also. That
Okay.
for each core, they
Mhm.
say there is at least two threads are there, or two
Okay.
OS threads. Okay, two
Mhm.
OS thread. So when we say like let's say in Java and other languages, right? They all
Mhm.
run on these OS threads. Okay, so let's say
Okay.
you have if you have a laptop which has four core, right?
Mhm.
So there will be two eight threads, OS threads.
Okay.
Okay,
4 into 2. One
uh,
core means two
two
thread.
two threads. Okay, so that's how what do you call when you say about multi-threaded programming. So
Mhm.
in like Java or C Sharp,
Mhm.
essentially each program runs on a thread, OS thread. Okay,
Correct.
now in case of Go, and so if you like, and because it's running on the OS thread, right? So
Mhm.
essentially, what's happening that the execution of your program is in
Mhm.
control of your kernel,
Okay.
right? You know, because kernel will tell okay which because context switching happens a lot on these OS threads, right? And
Mhm.
in each OS thread, you have some stack, the local memory. That's like I think heap or stack. We have the memory
Mhm.
allocation happens, right?
Yeah.
So
Correct.
that
Correct.
stacks if when a process is running, so that
Mhm.
stack gets into RAM. Otherwise,
Okay.
it's like written saved, but
Mhm.
while that is
Okay.
not running, right? Now,
Fine.
but
Yeah.
in case of Go routine,
Mhm.
now each Go routine does not actually, okay, it does, but in a different, so each Go routine, right?
Mhm.
So in case of, let's say, we talked about this thing, right? Each process runs on threads, right? OS thread,
Mhm.
right? Now, in case of Go routine,
Any
scheduling,
application, if you are using the each process is run, it will run with the threads, correct?
yes, threads. But
Mhm.
now let's say again, this was the way they started. Okay.
Okay.
Now, if you look at let's say Java or C Sharp, where you actually have the threads, what they do
Mhm.
is they have a thread pool.
Okay. Okay.
Okay. So what that means is they allocate a fixed number of threads. Okay, for
Mhm.
your Java
Mm.
application, and then
Okay.
the Java processes inside that they will keep switching on the OS threads. Context
Okay.
switching will happen. Now,
Mhm.
the problem, or you can say the difference between Go routine and the normal the threads, right?
Mhm.
The Go routines, first of all, their stack, the memory footprint, right? That's
Okay.
very less. Essentially, like generally, it's like in 2 kilobytes. Okay,
Oh, okay.
but for
Okay.
in general other processors threads, right?
Mhm.
The they have is like 2 MB. Okay,
Oh, okay.
so first major difference is here only, right? Now imagine if you have to, if you're doing like very fast switching between
Mhm.
process,
Okay.
time to read and or write will
Mhm.
be bigger in case of threads, right? Because it's 2 MB, it's a lot, right? And here it's 2 KB. Of course, it has become different. If it has, they would have fixed it there as well to some, but I'm right. But
Yeah.
this is how it all started. But other major difference between Go routine and threads is the. So I talked about, right, how that kernel is responsible for scheduling. Here, kernel is not responsible. Here, you're in the when in your Go this thing. There's we have the Go runtime, right? That
Yeah.
is responsible for scheduling. Okay.
Okay.
All right. And now what it does is, if you like, if you read this article, there's a actually bigger article. Let me see. There should be here. This one, scheduling in Go. Correct. You should read this entire series. Okay.
Oh,
Basically, it will
okay.
talk about the same thing which I am telling you. Okay.
Mm-hmm.
Essentially, what it is saying is, in the Go runtime, right? This is the this entire thing is controlled by Go runtime. Here, each processor, each process, okay. So this is your core. This is your M. Okay, I forgot what is M and P. Let me just revise that. I keep forgetting about this thing. This will talk about all of these two things.
M means memory.
No. M is not to memory. Here it will talk about core scheduler. Yeah. See, OS each every P is any program which may be eight process, and every P is assigned to OS. M is for machine. Okay.
Oh, okay.
M is for machine and P is for this one. Okay. So essentially what happens, right? For each process, or what is P? Forgot again. Each OS thread, basically what are they are saying, right? OS thread has a runtime this local runtime queue. Okay.
Okay.
This one, local run queue. And then there is a global run queue. Okay. So okay, we can talk about this later. Again, at a high level, what is happening, right? Go runtime is responsible for scheduling your Go routines on each OS thread. Okay. You get the
Okay.
point?
Yeah.
Now, why it's faster? There are two things. First of all, it's faster because the memory footprint is very less. Okay. Second
Okay.
thing, why it's faster is what I was saying. Memory footprint, and second thing is this. When Go runtime schedules a Go routine onto an OS thread, right? It only does it when it needs to be CPU bound task. Okay. Now
Okay.
there's a difference, right? There are two
Yeah.
kinds of tasks we have: CPU bound or IO bound. Okay. So what that means is, CPU bound is like, let's say if you're doing some calculation, right?
Yeah.
Maybe A plus B plus C. That's your CPU bound. Okay. But IO bound is essentially, let's say if you're reading from a file, okay, or you're writing to a file, or you're doing something on networks, right? Like TCP/IP or UDP, anything like that, right? All of those tasks are IO bound.
Okay.
Okay. So what Go runtime does, while it's scheduling tasks, right? If it sees the Go routine is now going to do anything related to IO bound, then it will move it to blocked state. Okay.
Oh, okay.
And that gets picked up by a different Go routine, which is a different process which is responsible for handling IO bound task. Okay. And then on the process, this one, OS, what is this? OS threads which are running, they become responsible only for CPU bound tasks.
Oh, okay.
Okay. So that's one of the major difference here you'll see. Okay. And this is what, if you see in here, they talk about. Okay. So they essentially, like, the Go routine term, right? That came from cooperating scheduler. So
Oh,
in
okay.
general, like, let's say other C# or Java, right?
Yeah.
When what they do is to make sure that, let's say if you have five processes running within an application, and to make
Okay.
sure that each of them get enough time to run, okay, they preemptively interrupt the processes. So let's say like you have 5 processors running, right? And let's say
Yeah.
all 5 of them are CPU bound. Okay.
Okay.
So what they'll do, okay, the first one will run. It will run for, let's say, if it is decided the kernel that okay, every 5 minutes I will interrupt it. So every okay, the time I'm just telling randomly. Okay, I'm not sure what is the internal time they look. Maybe I should look it
Okay.
up.
Okay.
But let's say it's 5 minutes. So after 5 minutes, it will interrupt it.
Mm-hmm.
Okay, and then we choose another process to let it execute on the OS thread. Then again, it will interrupt that one also after 5 minutes. That's a preemptive scheduling. Okay, in
Okay. Okay.
Golang, it's essentially cooperative scheduling. Okay, so cooperative scheduling is basically here. There's a explain. Kernel. Here it tells me. Scheduling is well defined units, human separate, but season. Okay, scheduling needs well defined user space events. I forgot what. Essentially, the cooperative scheduling meant that each process or go runtime will itself let it go of the process. But I forgot now what was the reason for this thing. I'll
Okay.
need to look into this part more. Okay. But yeah,
Mm-hmm.
if you look at this thing, right? Like these are the, I was telling the waiting, runnable, and executing. These are the like the 3 states there are. Okay. And if you go below here, then there's a garbage collection, this asynchronous, and then like all these this particular part, right? LRQ and global run queue, that is
Yeah.
essentially kind of queues they are maintaining at each for each process or each OS thread. Okay, so let's say if you have 3 processor or 3 OS thread, right? So all 3 of them will have local run queue. Okay, and then there will be one global run queue. So what happens that each go routine will first gets pushed into the local run queue, right?
Okay.
And for let's say there are 3 of these are running, right? Let's say if any one of them gets emptied, then it will pull from global run queue. Okay,
Okay.
so this you can read in more detail here. Okay, I'll send you this link as well. Okay, so
Okay. Fine. Fine.
that
Yeah.
is what essentially go routine is. Okay,
Got it.
you
Yeah.
understand, right? What's the
Yeah. Yeah.
difference and why it's better, right?
Yeah.
Okay.
Correct.
Okay. Now the second thing is
Mm-hmm.
you asked about is okay. First, so before I move, any other question or concern about Go routine?
No, no. Go routine. Let me try it from my side. Means I have to try it again. Then,
Hmm.
one thing is, I know some. What is that? Wait group we have to create, and
Uh,
that things I know. Now I got it. Anyway,
hmm.
I will read this document. Okay.
Ah, and
Yeah.
other okay. So from the programming side, right? What I'll tell
Mm-hmm.
you is okay. Try doing this kind of thing. So let's
Okay.
say we write a simple main function. Okay,
Mm-hmm.
I'll actually maybe we'll do it here only. Okay. So the Go, right? To better understand the Go routine. Forget
Mm-hmm.
about the weight group and others. Okay, just like
This
understand
one,
how
which
the
ID?
Go.
This one?
This is Goland. Do you need
Oh,
a
Golang. Okay.
license
Okay.
for that? I think. But yeah, you
Yeah.
can do it other places as well. So
Okay.
simple way or to understand everything about Go routine, right? You have to
Mm-hmm.
write different variation of the program. Okay.
Okay. Okay.
So let's say like if let's say if there is a function, okay, and if I just call go on it, okay, so you understand, right? Like
Mm-hmm.
if you just call go on it,
Yeah.
then this function, because see the main function itself is a go routine, correct?
Correct. Correct.
है ना? And then you launched another, so this is how you can launch any go routine inside it, right? But
Yeah. Yeah.
if you just write this much, that what happens is
Mm-hmm.
this function's execution will not wait will not wait for, oh sorry, main function's execution will not wait to finish this one,
Okay. Okay.
right?
That means main
Okay.
function will not wait for to
Let's
complete
say
this go function. Yeah,
let's say this is
inside
come
function.
one.
Yeah.
Okay. So this will not wait. Now,
Mm-hmm.
how do you make sure it waits? So right. So that's
Mm-hmm.
when you can do like multiple things. So like maybe you have a channel which tells it to close, right?
Mm-hmm.
Or you
Yeah.
can do a wait group. Those are the other things. Okay, but
Mm-hmm.
I
Okay.
think this is explained here as well. Let me see. Go to uh, done. What was the top left cable just okay, here it is. Mm, Yeah, you did you go through this thing?
Yeah.
Okay,
Mm-hmm.
yeah. So, mm. Okay, well, I'll do one thing, man.
Mm-hmm.
Now that you mentioned it, right? So today you go through this basics about this film, and definitely
Okay.
go through this also.
Mm-hmm.
Tomorrow, right? I
Yeah.
can come up with few exercise.
Okay. Okay. Fine. Yeah. Yeah.
Okay,
That's fine. Yeah.
है ना? And then I can ask you like, okay, tell me what should the output be, what should be the output, and then you
Mm-hmm.
can if you're going wrong anywhere, then I
Yeah.
can help you understand why that's wrong. Okay,
Yeah.
okay.
Correct. Correct.
I'll take this next one on me.
Mm-hmm.
Right, go routine exercises. Okay. Okay. So
Okay.
you
Okay.
should go
That's fine.
through that and definitely
Mm-hmm.
go through this as well. I'll send you this
Yeah.
link. Okay.
Mainly from this basic or advanced level, we should
Hmm.
understand Go routine and var. What is that? Variables. Uh, that is enough for a basic level of Golang.
Yeah, yeah,
Correct?
yeah,
Yeah.
yeah, 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 yeah.
Mm-hmm.
Correct. Where declaration is that you can do like let's say if you pick up any
Mm.
simple like lead code exercise as well, now you will pick
Yeah.
it up.
Yeah.
Okay.
Okay. Okay.
So the Go routines, yeah. For that, I'll write some exercises and then we can
Mm-hmm.
work on those to solve
Okay.
them.
Okay. Fine. Yeah.
Okay.
Yeah.
That's one thing. Now coming to channels. Okay.
Mm-hmm.
So channels are essential here also. I think it will be there. I think uh, this one concurrency. No. Okay. So this doesn't talk about. Okay. It doesn't talk about channels, but in a different way. Okay.
Mm-hmm.
So you should definitely look at all these three articles. Okay. These are really
Yeah.
good. You should read them through and you can ask me any
Can
questions
you
about these as
send me this article on
yeah,
chat
yeah.
or something?
I'll send you both. I'll send you both of them.
Yeah.
In that WhatsApp group, na, I'll
Yeah.
send you
Correct.
both of
Correct.
these.
Correct. Correct.
Okay. All right. Now coming to channels part, right? Channels
Mm-hmm.
are essentially used for communication between Go routine or
Go
between
routine. Yeah.
Go routines, right? Now channels are of three different types, right?
Mm-hmm.
You have three the, huh, there is a buffered
Mm-hmm.
one that is where there is no size, right?
Okay.
And okay, actually there are two, then they divide more. Okay, so one is basically there which in which you don't define any size. Okay,
Mm-hmm. Okay.
right? In that, essentially, what happens is essentially, right? If you let's say you have one process running, right,
Mm-hmm.
in which you are sending something to a channel. Okay, and another process, let's call this P2. Okay, so let's call this P1,
Mm-hmm.
where you are receiving from a channel.
Okay.
Okay, okay. A channel is again, it's
Channels means it's kind of pipeline, correct? Na? You are sending data through pipeline.
yes, yes, yes,
Okay.
yes.
Okay.
Now, and the way to create channel is like something like this. I think make chan int
Channel.
something
Yeah.
like this,
Mm.
right? So this is telling you that, okay, my channel is of integer, in which you can only send integers, right?
Mm-hmm.
And it's a reference type. Again, remember this. It's not a value type. It's a reference type. Like
Reference type.
how, right? Now here there is another optional parameter. Okay, you can put size here. Okay,
Okay.
maybe 1, maybe 2, maybe 3,
Mm-hmm.
or maybe even 0 as well. Or you can completely omit it. Okay,
Okay.
so if you omit it, then what it means is that if you're sending here and receiving here, right? So let's say you have sent some value here in this one process, right? So this process P1 will be blocked until that value is read from this channel.
Okay. Okay.
Okay, so that essentially means is if I have sent, let's say from here something, I cannot send anything else to this channel until somebody has read it from here.
Okay.
Okay, then now similarly, if let's say if you define capacity here, okay, right, like 1 or 2, then it what it means is you can like keep sending till you buffer it. So like the earlier you saw, right, the problem was if I sent 1, I'm blocked until unless somebody empties it, right?
Okay.
Now here you're saying, let's say if I put 2 here, okay, so I can push 2 elements. Okay, well after pushing 2, again I need to wait till it gets emptied.
Yeah, correct.
And that's the difference. So if you just go here, go routine, go channels, I don't know what this is. Declaring channel, I have here, then sending and receiving, right? This is read, that's write. Okay. Sender block. See, senders are blocking by default. Okay. That's something. So you can like write this kind of program as well and do this.
Okay.
Then run program background. There should be buffer as well. Deadlock, indirectional, closing. Yeah, there is this interesting thing is about the closing as well. So
Okay.
this I forgot. So you can close a channel like something like this. Okay. If you close a channel, that means you cannot send anything more to this channel. Okay.
Okay.
And also you cannot receive it also. Basically, both sides will be closed. This is helpful in case of. I should write some exercise for this as well now. Forgot. Okay. I'll write some exercise for gender, different scenarios of gender. Okay, I'll do this. My bad.
Okay.
This is actually okay. For loop, and this will be straightforward.
But in lead
Okay.
code, I'm not able to find Go. I can see Java, JavaScript, and Python also, but Golang, it is not there.
Oh, it's there. I do it. Yeah, it's there. What let's say lead code. Okay, it's asking. Okay, it is asking. Yeah, it should be there. See? Yeah, here it is, no?
Okay, okay.
Go.
Okay, got it, got it. Where is this one in play?
No. If you just go to problems, you will see it. Yeah. Let's say if you open any problem, you should be able to see it.
Okay, okay, okay.
Let's say if you go to this one, do some, you probably ask me to create an account. But it should be there. See it.
Even Go interview time also, they will ask you to ask us to write a code based on this. Oh my God.
Yeah. Correct. Okay. So yeah, I'll get you some exercise tomorrow for both
Okay.
of these two things. Okay.
Okay, fine.
But
Yeah.
essentially there are two types of channel, unbuffered and buffered. Okay. Unbuffered
Okay.
is essentially when you have empty, no capacity, right?
Mhm.
And otherwise you have capacity defined. Fundamental thing difference is like here you can it's uh, what do I say? Blocking
Mhm.
channels are essentially blocking. Like if you have to send it,
Okay.
then you have to receive it also before you can send it again.
Okay.
Okay. So tomorrow I'll get you these two things,
Mhm.
right? So then we can walk through them.
Yeah, correct.
But other than that, what else? And
No,
I'll see.
only these two things and error also. Panic, that things.
What do you mean by panic?
Error case, no? Error case in Go.
Mm-hmm.
That one.
So in general, right? I think in Go, what is preferred that let's say if you have any error
Mhm.
from a function, right? You should do always return it.
Mm.
Okay, so that's like let's say you have a function, right? Called I don't know, do something, right? And
Okay.
there is input, and then the output is because you have multiple parameter output, right?
Mm.
Multiple variable, right? So you can always return it like this.
Okay.
Okay.
Mhm.
So why we do it this way? Because we want the error to propagate till the higher level. Okay.
Okay.
And
Mhm.
where the caller is, right? You should never like return some empty value or something. Always return directly the error. Okay.
Mhm.
And error
Okay.
is anyway a type. So like you can define a new error by like doing something like this errors dot new, and you can just put text here,
Mhm.
anything. Okay.
Okay.
Or if you want to be like let's say if you want to parameterize it, right? Then
Mm.
I think there is this thing called FMTF. The FMT package is there. There is
Mm.
I think this is the one. Error F, then you can say like let's say you have a integer variable of something, right? So you can
Correct.
put
Correct.
like that variable, like say I don't know v1,
Yeah.
something
Yeah.
like this. So you can do like this. And if you want, in case if you're a hand, so this is the how you can propagate the error. Okay. But
Mhm. Okay.
now when you talk about handling the error, okay,
Mhm.
so you can always so there is one type called panic. Okay, in Golang. If
Mhm.
you call this, then it will throw like exception at that point and it will crash the application.
Mhm.
Okay.
Mhm. Okay.
Let's say there are some errors, right? Let's say we want it to panic. So
Mhm.
then this is how you can handle it.
Okay.
But let's say if you don't want to panic it, you just want to handle it. So then we
Mhm.
can call this recover and
Okay.
handle
Okay.
it gracefully.
Mhm.
Okay. So these are the two ways how you can handle errors. And I'll try to get you some exercise for this as well tomorrow.
Okay.
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 Error call and handling. Basically, like what I'm thinking, right? So actually today it was because I did not think of it earlier,
Mhm.
right?
Okay. Mhm.
Whenever you have any questions on something, you just like you know
Ask in
tell me,
WhatsApp.
and then next day
Okay.
I'll come up with exercise and then we can walk through them. That's
Super.
better,
Yeah. Yeah.
right?
Yeah. Correct.
Than
Correct.
talking about the points.
Mhm. Yeah. Correct.
Okay. Because this is all like whatever I'm telling you, this is all theoretical knowledge. You can
Mhm.
read it like from online, but you're not getting anything new, or you're
Okay.
not learning
Okay.
anything new, right?
Mhm. Yeah.
So
Yeah.
yeah, I can do that. So
Yeah.
this
No
was
problem.
about I'll do
And one
that.
more thing, our
Hmm.
next level also we will cover this. Means go routine, error, everything. It
Hmm.
should be there. Correct now.
What do you mean?
No, no. See, for example, if we are start building that API or backend
Hmm.
application,
Hmm.
it will cover with the go routine,
Yeah,
error, everything is there
yeah,
now. Yeah.
yeah,
Okay.
yeah,
Okay.
definitely. So that's what I'm saying. So these are the concepts, but let's say
Mhm.
we were actually discussing about the course manager, right? So
Yeah.
did you decide like where will you start it from, or do you want me to tell you like how do you want to start that
Mhm.
implementing it
See,
basically?
implementation based on real time, we can start it. Means, see,
Sorry,
for
I didn't
example,
understand.
if I'm going to new project or new company, if I'm working as a Golang developer, how, see, this requirement came to build a one class management system. Where we will start it in real time. Same thing we can
Okay,
follow
okay.
here also.
Okay, okay.
You're getting my
Okay.
point.
So
Yeah.
let's, yeah, I got your point.
Mhm.
Okay, so let's talk about that on today, right?
Mhm.
So course manager you're talking about,
Yeah.
and we talked about in that there are two classes, right? The
Mhm.
main objects. One was teacher, right?
Mhm.
Then there was student, and each
Correct.
teacher can have multiple courses, right?
Yeah.
So what I want you to do, well, I'll of
Mhm.
course get you these things tomorrow,
Mhm.
right? So
Mhm.
now tomorrow you should have uh,
Mhm.
uh, so okay, how will we structure this, right? Think about it this
Yeah.
way. Wait, where is that? Uh, 1 second. No? But, yeah.
Mhm.
Okay. So first thing we'll do, right?
Mhm.
And that should be the simplest one. We should implement the simple CRUD service.
Correct operation. Yeah.
Okay. That should be
Mhm.
the
Okay.
easiest thing, right? To
Yeah.
start
Correct.
from, right? So we talked about teacher, student, and
Mhm.
then actually there is one more entity, courses,
Course. Yeah.
right? Because each teacher can have multiple courses. So there's essentially like a table. Okay. Later we can link it with table data model as well. When I say data
Mhm.
model, I mean like a database you can create in which you can create table. But for now, let's just start with creating these entities. Okay.
Mhm.
Now, if you so should we? I think MySQL will be simplest. So what you can do, right? You can
Mhm.
also do you have like the code setup like VS Code or whatever you use
VS Code. Yeah. I
for
have.
Golang?
Yeah. VS Code. VS Code is
You have
there.
setup, right?
Yeah.
So uh, do you also have MySQL server installed on your laptop?
Yeah. It is there. It is there. My SQL is there.
Is
My
there, na?
SQL also there. And Postgres
Huh,
also there.
huh.
Mhm.
Okay. But we start with MySQL. Okay, so in
Okay.
MySQL, you should create one database. Okay,
Mhm.
I'll write it down. Okay,
Mm.
uh, for MySQL, create a database. Okay, I know, in which
Mhm.
you'll have three tables:
Course, student,
uh,
teacher. Correct.
teacher, student, and courses. Okay,
Yeah.
do you want to design the table yourself first and then get it reviewed by me? And
Okay.
you know, okay,
Yeah. Yeah.
so and then on top of that, create a simple CRUD service. Okay,
Mhm.
where you can create a teacher, create, update, delete, all these four operations, CRUD option
Mhm.
for teacher, student, and
That
course.
that I don't. Is it we have to create in database side or Golang side?
Golang.
Golang
In
side. Okay.
database, we'll just create table. Okay,
Okay. Okay.
and you can create like a schema as well. Like let's say teacher, you can have an ID, the name,
Mm-hmm.
right, and
Mm-hmm.
maybe the courses they teach. So
Okay.
maybe wait. Will there? So you'll have one teacher. You will have. I'm just thinking. Once you have teacher, you have student, you have courses. Then I'm just thinking like so we
Mm-hmm.
courses okay, but for classes, how do we specify the relationship between these things?
Mm-hmm. Okay.
So
Okay.
student is attending which are
Or
classes.
one more thing, we can start with a simple thing. See, 1 second. Actually, I made one front end, nothing. I just login page. Then before logging, you have to register user with your email ID, blah blah blah. Then after that, you have to log in with that user ID. Then we have to see some like a search window or something. Okay, that search window is integrated with ChatGPT or Google Chrome, something like that. Okay, it's very simple. Let me open that one second. This is simple HTML code only. Okay, what I'm going to do, there is two button in front page, sign up and login. If you click sign up, it will go to registration page. There you have to enter your full name, username, then email ID, phone number, password, then gender select, then click register. Then you will get a your ID is registered. Okay. Once you registered, then you have to back to here. You need to log in. Okay. This one leave it. This Facebook and Twitter leave it. Maybe we have to use authentication. What is that? Auth. Auth we have to use. But leave out this one. Once we logged in here, then we will make one more page. It's kind of index something home page or something. Then inside home, we will just create see search content search. Okay, if I am typing Google, then that Google need to list below. Same Google. See, you are searching Golang, then it will display here. Okay, whatever Golang is there. Same thing we can also make it here without adding this one. For example, you can just link with the Google search window or chat GPT or something. We can link now. In such a time also we can link that option.
But for that, you don't need Golang, right? I don't think.
But creating user, this one again, it will come to backend, correct?
Oh, okay. Creating user side.
Yeah. See, we will start with one user creation and how that will work with the. Okay, leave about that search also. That I will make it. But I need to understand how to make that user integrated with email ID and something like that. Means a small database. Maybe we can use SQLite or Postgres or MySQL also we can use.
Yeah. Any of those three will work. Okay. All right. So that should be simple, right? We can simply create one table. So forget about like OAuth for now. Let's use like simple email password registration.
Correct.
So you create a table called user in your database, right?
Okay.
Then you create a there is this library in Golang called Gorm. You can use that.
Yeah, Goro.
Okay. You can use that to basically run. Okay, I can show you something which might help you understand the end-to-end flow, how it works.
Okay.
So let me show you maybe. So other tabs. So where is MySQL database? Okay, so can you stop sharing? So now imagine here, right? So you'll create one package essentially like this. Like I had put like MySQL database. Okay. So in which you'll have one models. Okay, and what it is doing is essentially we specify everything here. Okay, this is very straightforward. You can find this. Essentially, I'm not doing anything here, right? I'm just creating database client, right? And this is the GOM library, and I'm opening the connection, and then here's the closing and everything, right? Recheck, you can forget about those also. But this is the main interface, right? In this interface, what happens? Not sorry, this one. So here, if you notice, right? So let's say this is like my position table. Now, in case here, your case it will be user, right?
Okay.
So whatever the column names you have, you'll create a structure on top for that, and you can refer the column name like this. right?
Mm-hmm.
And then you can define functions directly using either like create user, update user, or delete user.
Mm-hmm. Mm-hmm.
Okay. So similarly to what this struct you have, you need to create another struct which will actually pass from the back route handling, wherever that router connection will be
Yeah.
handled on the server side.
Mm-hmm.
And then you can create the row. And how it happens, you just
Correct.
create this position row, and then you create a transaction and you commit it.
Mm-hmm. Okay. Okay.
Okay.
Mm-hmm.
So yeah, I think the first is okay. The sample code for this, I think we should be able to find online as well. Nowadays, actually, I think we should like, let's say if I do maybe open chat and if there's something there, I'm
Mm-hmm.
sure like nowadays all of this is essentially like very boilerplate code, right?
Oh.
So
Oh. Okay.
so you should be able to find this on even chat GPT.
Mm-hmm. Okay.
So let's say we want to I have a user table in SQL, write code in Golang, create, update, modify user. Okay. This is using MySQL driver. You can use Gorma also, right?
Mm-hmm.
So
Okay.
essentially now you see what's happening, right? It's for
Yeah. Yeah.
connection, creating, and now essentially what I've done in my
Mm-hmm.
case,
Mm-hmm.
all of this is separated into different files, right? They're
Oh,
like
okay.
layered, right? See,
Mm-hmm.
this is for creating and opening and closing
Connection.
connection. Then
Mm-hmm.
this is for creating the table. Of course,
Okay.
this will already be created, so we'll not write code for this, right?
Mm-hmm.
We'll
Mm-hmm.
assume our database this table is already there. We'll write code
Okay.
for this, and this, right? And you'll
Mm-hmm.
have different
Mm-hmm.
functions for it.
Okay. Okay. Okay.
Okay, like it is here. So you just pick
Okay.
like something like this, and then we can, like I can, like once you write the basic code, then
Mm-hmm.
I can tell you how do we modify it and make it like a production ready code.
Okay. Okay. Fine. Yeah. Yeah.
You know?
Got it. Got it.
Okay.
Yeah. Yeah.
So you can write this tomorrow and we can review it. Okay.
Okay. Okay. Fine. Yeah.
So that's for you. Okay. Tomorrow to write
Mm-hmm.
the uh, Golang code for the user CRUD operation.
Yeah.
Okay. And create table in the database which you prefer.
Mm-hmm. Okay. Then tomorrow you will show me how to connect this backend to front end.
Uh, so let's say if you are by backend, you mean this will be ready, is it?
Mm.
Okay. So if this is ready,
Uh-huh.
yeah, then we just need to create server, web server.
Okay.
Okay. So essentially, again, let's say your backend is ready, then web server should be straightforward.
Mm-hmm.
Okay, fine. And then we can, okay. Okay. So I'll keep the boilerplate web server code ready.
Okay.
Okay, for
Mm-hmm.
you. When I say boilerplate web server code ready,
Mm-hmm.
okay. So basically, I'll create something similar to this user CRUD thing only, okay.
Mm-hmm. Mm-hmm.
And then yeah. So you also finish this part.
Okay.
I'll finish these four parts and we can walk through them.
Sure.
Okay.
Yeah. Yeah. Yeah.
Now in my case, of course, because I don't have front end, I'll have it ready by
Mm-hmm.
using Postman.
Post. Okay.
But yeah, if you have the front end, then you can just plug in those APIs directly
Mm-hmm. Mm-hmm. Yeah.
and
Correct.
just to host it somewhere. Okay.
Mm-hmm.
What else?
Okay. Okay. That's it. Because
Okay.
slowly we can start these things now. Then I will
Ah,
also get uh, what is that experience.
yeah, definitely. Okay. In
Mm.
the meantime, you should read these two. I'll send you the. Okay, so
Normally,
tasks.
what all are our roles and responsibility if you are a Golang developer? What is your day-to-day work in Golang side?
Yeah, just 1 second. I'll write. The name is spelling.
Prashob,
Sure.
P-R-A-S-H-O-B. Yeah,
Okay. ERANCTOB.
S-H-O-B. Yeah.
Okay. Links also. Okay. So the responsibilities are similar, man. Like basically, if you're working on a project, then like it depends, right? Let's say at which level you are. Let's say if you're a junior level, then the task will be assigned to you. You need to finish those tasks, right? It could be feature or it could be bug fix. If you're at a
Okay.
senior level position, then a problem schedule will be given to you, and you need to break it into smaller tasks, maybe with the product manager or project your team lead, right? And then divide the work and then work on those tasks. And but
Okay, okay.
yeah, it will be something like that.
Okay, fine. Yeah.
Okay, so I'll send this in the chat, WhatsApp. Okay,
Okay.
so this will help you as well and me as well. And if you want to add something else to it, please feel free to add.
Sure.
Okay.
Yeah.
Okay.
Okay,
Anything
then.
else?